I don't need them, so I don't care. Oh, we're recording. Okay. This is 6.1, day number 2. We're going to talk about intermediate value theorem. Identify multiple zeros and what happens at those zeros, as well as make a sign chart. Let's go. Okay, so a polynomial, we talked a little bit about this, or I talked about it in the video you had yesterday. A polynomial's coefficients must be real numbers. So each of these a values, an minus 1, has to be real. Okay, so you can't have a square root of negative 1 as a coefficient. What has to be true about the powers is that they are natural numbers, meaning 1, 2, 3, 4, 5, 6. You can't have a fractional exponent or a negative exponent. And the only other thing is that the domain of the function must be all real numbers. There actually is a caveat to that. A polynomial will never have a cusp or a corner, so the absolute value function will never be a polynomial. Okay? And a polynomial is smooth everywhere. There are no gaps. There are no asymptotes. Okay, so far so good? All right, let's talk about the intermediate value theorem. I call this the don't be stupid theorem. Okay? Here's why. This is what the intermediate value theorem means. Okay, let's say that I have a puppy. Aw. What should we name this puppy? Fred. So Fred, at 6 months, is 6 inches tall. Aw, Fred, you're 6 months old. You're 6 inches tall. You're going to grow, Fred. You're going to grow. And Fred at 12 months is what? What do I have here? 14 inches tall. Okay, now, that means that at some point in between, let's say at 8 months. At 8 months, Fred will be somewhere in between 6 and 14 inches tall. That makes sense, Mr. Ludd, because his growth is going to be continuous. There's no gaps there. Polynomials don't have gaps. It's not like Fred is 7 inches tall and then all of a sudden just like gains and instantly is 2 inches taller than he was instantaneously. No, that doesn't happen. Teenage boys, they do grow quickly. Some quicker than others, but none. You'd probably die if you grew 2 inches right now. You'd be like, oh, and your heart would just give out. Your bones would just disconnect, and you'd have to get stitches, and then you'd get a concussion because you fell over because you couldn't control your body. And then nobody would want to go on a date with you because you wouldn't be conscious, and when you woke up, you'd be like, ah.
Sounds like personal experience.
What? That's not a personal experience. Okay, now there is another application to this. Here is the application. Let's say that f of a is negative 3. Right? Let's say f of a is negative 3. So here's a, negative 3. And let's say f of b is positive 7. So here is b positive 7. What does that tell me about this polynomial in between? That somewhere it has to equal what? 0. Yeah, that's what the intermediate value theorem is. It says that for some value c, and that value could vary, but for some value c, it will have to cross the x-axis. Okay. That's the intermediate value theorem. All right. Let's talk a little bit about zeros, multiplicity, and behavior. Okay, so let's look at this polynomial here that's in factored form. Somebody holler out one of the zeros. What value would make this whole polynomial equal 0? 3 is one of them. Okay, 3 is one of them. 9 is another one. And 6 is the third one. Now, the multiplicity of the power of the factor that gives me 3 is 5. If you have a multiplicity that's odd, what will happen is your polynomial will pass through that point. Will pass through that point. So I'll show you what that means in a moment. So it'll pass through there. Do I have another odd degree? Yes, I do. 9 is a power of 1, so its multiplicity is 1, so it will pass through that point as well. Now, the 6 has an even power, so its multiplicity is even, therefore it will bounce at that point. So let's make some sense out of this. All right, so zeros, 3, 6, and 9. Okay, so here's 3, here's 6, here's 9. Oh, how convenient. Okay, before we sketch this graph, we know 3 points on this graph are here and here and here. What would the end behavior of this polynomial look like? The degree of this polynomial is 5 plus 2 plus 1. So the degree is 8. Will this polynomial open upward or downward? Upward, because each of these x's, x, x, and x are all positive. So the leading term, we talked about this yesterday, the leading term of this polynomial will be x to the 8th. X to the 5th times x to the 2nd times x to the 1st is x to the 8th. So end behavior, I know, will look like this. Up to the left, up to the right. All right, now let's talk multiplicity. It's going to pass through 3, it's going to pass through 9, and it's going to bounce off 6. So intermediate value theorem tells me this. It's going to pass through 3, so it's going to be negative here. All right, it's going to bounce off 6, and it's going to pass through 9. So is that perfect? I don't know. Is there some wiggle room there with like how far down your minimum values go? Yeah, there's a little bit of wiggle room. The things, though, that are important and must be correct are such. This, well, what the heck? Come on, give me a star. Oh, I got it. That, that, and one more thing. Can you think of it? The behavior. What else? What would be up here? What if I plug in 0 for x? The y-intercept, right? The y-intercept. And what would it be? Well, it would be negative 3 to the 5th times negative 6 to the 2nd times 9. And I don't know what that is, but it's going to be a really big positive number. Right? Okay. That thing keeps disappearing. All right, so with a neighbor, I would like for you to take a minute and write out all the zeros, all the multiplicities, all the behaviors, and then we're going to go ahead and do what's called a sign chart together. So take a minute, fill in the chart. If you want to try to graph it, you can, but we'll come back together and look at it. Okay, here we go. This term right here yields a 0 of 0. This term right here yields a 3. This term right here yields a negative 2. Why doesn't this term yield a square root of negative 1? Because it's imaginary, right? So don't be fooled, right? That's not a real 0. It's not a real 0. So this term right here does not give us a real 0 where it crosses the x-axis. But it does tell us something about the end behavior. Let's talk leading term. Okay, I have x cubed times x squared times x squared. X cubed times x squared times x squared. What would that be? X to the 8th again. Oh gosh, Mr. Ludd, come on, give us something different. Okay, so end behavior will look like this. Guess what? If I plugged in a 4 over here, that value on this sign chart would be greater than 0. Hence why the graph will go up from there. If I plugged in a value to the left of negative 2 on the sign chart, that would be greater than 0 as well. Do we have any bounce? We do have a bounce. The bounce is at 3. Okay, so you could sketch this graph. Boom, it would go up like that. It would pass down through 0, come back up through -2. So if you look at these values right here, look at the values to the right of 3. All those values are what? Positive. How about the values between 0 and 3? Also positive. How about the values between -2 and 0? Negative. And then all the values to the left of -2, they're positive. So that sign chart can be useful, but I like to visualize it a little bit better, right? I like to look at the actual graph itself. Now, there are 3 things that you need, right? You need to have correct intercepts or zeros, which would be each of these. And then you have to have correct end behavior, which I have. And the last thing you need to have is a correct y-intercept, which, conveniently, I already had. That's my y-intercept. It's also an x-intercept. All right, let's continue. Let's see if we got anything else left. Oh, this is the good stuff, guys. You guys remember long division? Oh, yeah, it's good stuff. Let's divide something. Dylan, give me a single-digit number, positive. 5, okay. Somebody else give me a 3-digit number. 471. Okay, so 5 doesn't go into 4, but does go into 47 9 times. So I multiply, I get 45, I subtract, I get 2. All right, I drop down the 1, and I get 21, and I see how many times 5 goes into 21. It goes in 4 times. So multiply that through, I get a 20, and I get a remainder of 1. All right? So my answer is 94 times with a remainder of 1/5. We're about to do that with the old polynomials. What? Sick. Let's do it. Okay, so let's say x equals 1 is a solution to the polynomial. So if x equals 1 is a solution, what is a factor? X minus 1 is now a factor of this polynomial, meaning that it divides out and has a nice polynomial as its divisor. So I'm going to divide x minus 1 into that and get a new polynomial. Because this right here gives me a solution of x equals 1. That's one of my zeros. I'm going to find how many more do you think? 2 more, hopefully. At most 2, right? Because it's a 3rd degree polynomial. It should potentially have 3 other solutions. So let's divide. How many times does x go into x cubed? How about x squared times? Now I'm going to multiply that through. X squared times x is x cubed. X squared times -1 is negative x squared. I'm going to subtract. Be careful. X cubed minus x cubed is 0. 3x cubed, 3x squared minus a negative x squared is actually 4x squared. I drop down a negative x. I start again. How many times does x go into 4x squared? 4x times. Multiply it through, I get 4x squared. I get negative 4x. I subtract that. 4x squared minus 4x squared is 0. Negative x minus a negative 4x is a positive 3x. I drop down a negative 3. Oh, this is going to work out nice. Okay, x times what gives me 3x? 3. 3 times x minus 1 is 3x minus 3. And look at that, I get a remainder of 0. What does that mean? That means that x minus 1 times x plus 4, 4x plus 3 gives me my original polynomial, this thing. Okay, so what would make that equal 0? Well, I already know x equals 1 would make that 0. Could I possibly factor this thing? Cha. X plus 3. What else? X plus 1. Cha. Oh, so wait. X equals negative 3. And, oh, watch this. X equals negative 1. Could I sketch this? Yes. Oh, that was terrible. Negative 3, negative 1, positive 1. I think it had a positive leading coefficient and it was a cubic, right? So end behavior should be this. Oh, Mr. Ludd, you're not fully accurate. What is your y-intercept? Oh, sorry. I'm going to plug in 0. 0 cubed is 0. 3 times 0 squared is 0 minus 0 minus 3. And that is the sketch of that graph. Whoa, you're so good at this. I know.